Algebra 1 review for sections 1.3 and 3.1 to 3.3. All right, number 1. The table shows the amount of money charged by local health club. Local health nuts. We have months, 2, 3, 4, 5, cost 30, 45, 60, 75. How would the rate of change be determined? So that's our question. When you see the words rate of change, it should trigger the equation y equals mx plus b. This value is called the rate of change. Rate of change, slope, rise over run. It's all the same thing. Okay? Rate of change, slope, rise over run. So, in this context, it's our rise over run, or it's our change in y. How is y changing? Over the change in x. Okay, you could write it like this. I wrote it like that a few times. I wrote it like the equation you might have learned in middle school that I touched on. The change in y over the change in x. But the way that I really emphasized it was to write it as a tiny table. Okay, so let's rewrite this up and down. And we have to know that months is our x. It's the first one. Cost is our y. So months, 2, 3, 4, 5. And cost 30, 45, 60, 75. Do you have to rewrite it? No, but I'm showing you the way we did it in class, because this is how you find your change in y over your change in x, and that is the rate of change. Okay, so y is going by 15 every time. You see that? So that's my change in y. X is going 2 to 3 to 4 to 5. It's going by 1s every time. So it's 15 over 1. Okay? How would it be determined? You find your change in y. You could write it as a sentence, or you could just say change in y. Instead of writing out change in, a little abbreviation is the triangle y over change in x. If you want to write that out, that's fine too. But what would it be? It would be 15, or 15 over 1, which is equal to 15. All right? Number 2, what is the equation of the line that passes through the point negative 4, 13 and has a slope of 0? Okay, when you think of a line with a slope of 0, you need to know it's one of the special cases. We had 2 special cases. I'm going to go over those now. We had a y equals a number. When I say special cases, I mean it's not a regular y equals mx plus b type line. If it's just y equals and it's some number, that gives you a flat line, a horizontal line. It's a 0 slope, just like the one in this problem. The other special case is when x equals a number, and that's what we call the weird one. It doesn't even start with y, and that is a vertical line that has no slope. All right, this situation is a 0 slope. When you see the word 0 slope, you need to be thinking horizontal line. Okay, so the way that helps you get this problem actually really quickly is, what is the y value in this point? It's 13. So guess what? If this is like my origin, I'm going to write it really low. If this is my 0, 0 point, my origin, this line has to be up 13. All the way up to 13. Let's just say this is 13 right here. There's my horizontal line. How do I know it has to go there? Because it's going to negative 4, 13. That point is on the line. And since I know the line is horizontal, that's the only way a horizontal line is going to go through negative 4, 13, is if it goes through all the y values of 13. So what's my equation? It's y equals 13. Okay? If you need to pause the video anytime, rewind it, study it, please take the time to do so because this review is built straight from the test, okay? The teacher made the test, and then they made the review to go right before the test. Okay, the table shows, number 3, the table shows the amount of money charged by a local health club. Now, if you'll notice, this is the exact same table as the one above it. Okay, so there's some information you might be able to reuse, and the test will have some two questions like that as well. Okay, it'll have two tables that are the same, very similar. So if you did some information up here, some math work, you might be able to use it down here. Determine whether the data in the table above represents a linear relationship. If so, what is the slope of the line containing the points given in the table? Well, we already did all that work. We found our change in y over change in x. This is going up by 15, 30 to 45, to 60 to 75. This is going up by 1. It is linear because this is always going up by 15 every time. This is always going up by 1 every time. So we have a consistent 15 divided by 1, 15 divided by 1, 15 divided by 1. So yes, that tells us it's linear. If it has a constant rate of change, it is linear. All right? Secondly, we already found the slope. It says, if so, what is the slope? It's 15. So the data is linear, and the slope is 15. Now keep in mind, let's say for some reason you were having trouble finding one of these. Well, just by seeing linear here, I've already gotten rid of choice A and choice D. Okay, so use that strategy as well. Figure out which is definitely not correct, and then you can narrow it down to what is correct. All right, let's do number 4. What equation would represent a line with an undefined slope that goes through the point -4, 9? That's the other special case I just mentioned up here. Let me zoom out so you can kind of see the problem and that. So this is what an undefined slope is. This is the one that is x equals a number. So let's keep that in mind, and let's go back to this. If it goes through the point -4, 9, which is somewhere over here, right? 4 to the left, 9 up, somewhere over here, and it's a vertical line, it's going to have to be a vertical line going right here, right? If it goes through -4, 9, and we know it's a vertical line because it has an undefined slope, this is my line. And what's the equation of that line? X equals -4, because the value of x is always -4. All right, let's do the other side of the front page. Question 5. The function f of x equals 2.25 plus 2.2 times the quantity x minus 1 can be used to determine the cost in dollars for a taxi ride of x miles. What is the rate of change of the cost in dollars with respect to the number of miles? So they're asking for the rate of change. Like I said earlier, when you see rate of change, you're thinking of this value. The slope, the rate of change, same thing. Now, the only thing is, this is not written as y equals mx plus b. We have to do a little bit of math, okay? We're going to go by the steps that we learned throughout the year. First of all, if there's distribution, do the distribution. And I see distribution right here. Multiply that out. 2.2 times x is 2.2x. 2.2 times -1 is negative or minus 2.2. All right? This is still in the front. I haven't done anything with it yet. So I have y equals 2.25 plus, and then all this other stuff. Now, I have a few different things here. I have a 2.25, I have a 2.2x, and I have a minus 2.2. Two of those terms are like terms, and they need to be combined. It would be the 2.25 and the minus 2.2. So 2.25 minus 2.2 is going to give you like 5 cents left, right? And if you're not sure, you can put it in the calculator. But basically $2.25 minus $2.20, because this is 20, not 2, right? $2.20 gives me 5 cents. So basically, I have 2.2x, that's this term that did not change, plus 0.05. Y equals 2.2x plus 0.05. So what's the rate of change? It's 2.2. It's the m value. Now that we have it in slope-intercept form, that's the value with the x. Now they want it in dollars, so I don't want to write 2.2. I want to write $2.20. Now, did you have to get the whole equation to get that? No. If you realize these are not going to combine with the x term, then you can just stop there and get it from there. Okay, number 6. While working on her report for World Geography, Piper noticed that her clock read 105, and the word count for her paper was 324 words. When she finished the paper, her clock read 205, and the final word count was 1,002. What was the rate of her typing in words per minute? Okay, so this is a wordy problem. It looks a little intimidating, but here's the key, the rate. They want the rate. The rate is my m value. They want this value. What do we know about that? It's my slope, my rate of change, it's my rise over run, and they're giving us a word hint right here. Words per minute. Okay? This is my y value. Words. I told you about the words per, each, and every. They help you find the slope. Well, this is pertaining to the slope. Okay? This is my slope in words. Words over minutes. So when I find the change in words, how did the words change in that time period, and then how did the time change? That's going to be my slope or my rate. So let's look at the words. The words were, the word count started at 324. Okay? So that's one of the numbers. Let me go ahead and make a tiny table just so we can get this all visually put together. So I'm going to have x and y, but I'm going to go ahead and write in words. I'm going to put words for y and minutes for x. So she started at 105, and this is a little bit different because we're dealing with time. Okay, so we're just going to have to count up the minutes, that's all. At 105, the word count was 324. At 205, the word count was 1,002. So, how many minutes transpired in this time? It's an hour, right? And an hour is 60 minutes. So 60 minutes went by. How many words went by during that time? Well, let's go ahead and subtract 1,002 and 324. So 1,002 minus 324, 678 words. So my change in y was 678. My change in x was 60. We want to reduce that to lowest terms. So 678 over 60. Now I get that. So it's 113 words every 10 minutes. Or if we get it down to per minute, it's basically like 11.3 words every minute. So either one of these answers is fine, but this would be the answer that you would want to put in this situation. This is an exception where you don't keep the fraction, because you don't want to say, you don't want the words per 10 minutes, you want the words per minute. So it'd be 11.3 words per minute. 11.3 words per minute. I'll just put WPM to save a little space. All right. Let's do these three, and we'll go to another video for the next page. Determine the slope of the relation. Okay, so we have input and output. So these are my x's, these are my y's. Let's find the change in y. 10 to 15 is a change of 5. 15 to 20, a change of 5. And there's a change of 5. So y is changing by 5 each time. Here we have a change of 1, a change of 1, a change of 1. My slope, or my change in y over change in x, is 5 over 1, which is 5. That's my slope. So after this extremely kind of hard problem, you have this extremely easy problem. All right, and it'll be like that on the test. There'll be some really challenging ones, very similar to this, and there'll be some easy ones just like that. Question 8. Which equation represents the line with a slope of 7 and a y-intercept at 0, negative 8? Again, this is an extremely easy question, all right? Just write out, if you want to, write out y equals mx plus b. What is my slope? It's 7. So it's y equals 7x. What's my b value? It's that value in that ordered pair. It's the y value. So it's minus 8. My equation is y equals 7x minus 8. Solve the following equation. X minus 4y equals 28 for y. Okay? So let's do it. I'm going to show you two ways. I'm going to show you the mathy way, and I'm going to show you on a multiple choice test how you can check your answer at the least and make sure you get it right. So if you have trouble doing this by hand, I'll show you how to do it in the calculator too. All right, so I need to get y by himself. Here's my wall. There's my y. The negative 4 is the one closest. That's the one multiplied. But I need to get rid of the one that's the positive one being added. This is a positive x. So get rid of him first. Negative x, negative x. So here I have 28 minus x. But I want to be thinking in terms of this order. So I'm going to put the x term in front. Instead of 28 minus x, nothing wrong with that, but I'm thinking to the future, I want it to be like this. I'm going to put negative x plus 28. All right? So on the left side, I have negative 4y. On the right side, I have negative x plus 28. Now I divide by negative 4 everywhere. So I get y equals negative x divided by negative 4. Remember, you can drop in that 1 that's been there the whole time. He's invisible. You can write him in. Negative 1 divided by negative 4 gives me positive 1/4 x. 28 divided by negative 4 gives me negative 7. So that's my equation. Now I want to remind you and strongly encourage you to practice putting a graph like this in the calculator, okay? You go to Home and you go to Graph. Now by default it has you graphing a function, meaning a y equals equation. But we don't have y by himself here, do we? We have this, right? If you hit the delete button right here below menu, you get a menu of options, and you want to go to option 6, relation. That gives you a whole different screen to input any equation you want. So I'm going to input my x minus 4y equals 28. X minus 4y equals 28. Okay, I'm going to get a graph. Now, you're asking me, well, how is that going to help me? Well, on a multiple choice test, they're going to have 4 answer choices, and one of them is going to be this, right? You could graph all 4 answer choices. The only correct one, the correct answer choice, will give you the exact same graph as the one I just put in. Okay, so let's hit Tab to get another graph in there. And I'm going to type in y equals 1/4 x minus 7. Now notice, since I'm in relation mode, I have to type in the y this time. Okay, so y equals, control divide, 1/4 arrow out to the right. Make sure my X is on the outside there, on the side. -7. -7. See, it's the exact same line. The red line went right over it. This is a surefire way to get these hard questions right on a test.